The next topic to discuss is the Python model. This has been updated a little bit more recently than the EES and the MATLAB model. So this one is part of the code base I'm using for optimization within the context of the Aora system. So I needed to have not just a model, but also input the appropriate assumptions. So I pulled it into this code repository, which contains a number of other models. And then, so it starts around here in August 2016. Do the conversion to Python, make sure that's running. About that time, I upgraded to Python 3 and then had to go through some conversion there. Not being wise about automatic code updates. So I was also working on some other thing. This is Adsorption update, and then so this is again like that cycle time optimization, updating, making sure that works. And then I was a little bit concerned about the heat input equation, the sign on that. And this later stuff is referring to the other models. So this is not very organized, but basically the code that's applicable for what we're looking at is this adsorption starting from there. So these files, let's see, anything else like what compare. So I think it's just these files, and there might be an IPython notebook. So let me pull up the tool I use for editing Python and show you what those look like. So I use a distribution called Python XY. This is maybe, or used to, I should say, Python XY. No longer updated. Use an IDE, an integrated development environment called Spider. Easier to use would be PyCharms. That's pretty popular and much more user-friendly. So to open it, I have to go in here. So it's unhappy with me now. Probably time to update some libraries. Anyway, so I guess I didn't use Python XY anymore. Just download Python for Windows. I don't know how to spell. Here are some command line tools that go along with Python. This I use a lot. I had to get it broken for a while, but that you can also get with pip and So this command line tool will install or download, uninstall. It's a package manager for Python libraries. And I guess the complaint I'm getting is some things need to be updated. So give me some time. And so I finally got that running, but I should note, so at least some of these updates departed from what we had in the MATLAB code. At this point, this q.in equation, somewhere in there I was a little bit worried about the sign of the terms in the equations that we had. So anyway, the biggest difference between the MATLAB code and the Python code is that I try to make the Python code object-oriented. So I have 3 files here. These are the main loops. Solution 9 again follows Gupta's main loop. Converge me follows my main loop. And adsorption.py just encapsulates all the functions, functionality, the supporting functions, I should say, the helper functions. So it starts off down at the bottom. These functions are the property values for fluids, having them all listed here specifically, what we're going to use. There's a main loop that just kind of checks out the things in this file, so it's just to make sure everything's working. There's a Freundlich object that encapsulates a Freundlich equation model for adsorption refrigerant equilibrium curves. So there's greater variety of the inputs that you can give and the outputs from this model, even including a spline version, which I don't know, that's a little bit crazy. There's a basic adsorption chiller model, which implements these time derivative functions and the integration functions, like this, using Python libraries instead of MATLAB built-in integration functions. And then system level calculations like the cooling capacity and coefficient of performance. And then there's the timing integration as well. So this object has methods for both the time integration scheme and the scheme where you compute curves in advance and then do interpolation.